The absolute value inequality of the form the absolute value of x minus c is less than or equal to d, where d is greater than 0, is equivalent to the compound and inequality negative d is less than or equal to x minus c, which is less than or equal to d. And if we solve for c, if we add c to both sides, it gives us c minus d is less than or equal to x, which is less than or equal to c plus d. This creates the compound inequality where x is the center, and you're moving c minus d to the left and c plus d to the right. The value, the absolute value of x minus c, represents the distance a number x is from a fixed number c on the number line. That's your center. It's no longer the origin anymore. And the inequality x minus c, the absolute value of x minus c, is less than or equal to d, means the distance a number x is from the center c on the number line must be less than or equal to a number d. So basically, you really want to look at your given inequality and see if it's less than. It's going to be an and a compound inequality. I like to use the trick that it's in the words. You have less than. That's how you can think of it, less than. And notice when you have that compound inequality, you're now having two different inequality signs. Even though it looks like less than, if you were to break apart this first inequality, this piece is really x is greater than or equal to c minus d, and you have x is less than or equal to c plus d. So this is a big idea that your absolute value inequality is splitting into two different inequality expressions, and your solution is right in the middle of them. It's just a way of writing it and helping you solve and graphing that solution. Let's look at one that actually has numbers. Let's look at exercise A. You'll have a better idea of what I'm referring to. So we have the absolute value of x minus 2 is less than or equal to 4. So right away, I see less than as my symbol, so I'm going to think that the graph of the solution is an and inequality. So it's kind of a good check or a good way to know where you're going. So I can rewrite this absolute value inequality as a compound inequality. I can write it as x minus 2, x is greater than or equal to x minus 2, and x is less than 2 plus x. So you have these two different symbols, two different signs. You can also split it up as x minus 2 is less than or equal to 4, and x minus 2 is greater than or equal to negative 4. And solve or simplify, and either way you end up with negative 2 is less than or equal to x is less than or equal to 6. You have a center of 2 with a distance 4 to the left or right, or you have the idea that you have the compound inequality where you have the endpoints of negative 2 and 6 and everything in between. Here are two more. So we have this idea, well, we have a little preview here. Let's see how we get there. So we have the absolute value of x plus 3 is less than or equal to 5. So less than, again, should be an and compound inequality that we can split up as either x is greater than or equal to negative 3 minus 5 and x is less than or equal to negative 3 plus 5. Or we can have the idea of breaking it up as x plus 3 is less than or equal to 5 and x plus 3 is greater than or equal to negative 5. Either way, whether you're solving for x or simplifying your values, you end up with negative 8 is less than or equal to x is less than or equal to 2, which is a center at 3 and 5 to the left or right, a distance of 5 to the left or right. Or you can think of it like a compound inequality where you have your endpoints negative 8 and 2 and everything in between. Here, C, we have the absolute value of 5 minus x is less than 3. So we split this, again, less than. So it's going to be an and compound inequality where we have the absolute value of x minus 5. They're just factoring out a negative 1. an absolute value of -1, so they're switching it around. So the absolute value of x minus 5 is less than 3, which does a split of x is greater than 5 minus 3, and x is less than 5 plus 3. So we can have this idea, or we can split it like x minus 5 is less than 3, and x minus 5 is greater than -3. You switch the sign and you switch the sign of both. So it's almost like a double switch. Think of the second inequality you write. You're going to have to switch this inequality sign and the distance sign. So 2 switches, which either way, if you solve for x or you simplify your values, you're going to end up with x is greater than 2 and x is less than 8. You also can think that x is greater than 2 and less than 8 is just another way of writing that inequality. Now let's take a look at, we've been looking at less than, let's look at what happens with greater than. So here, when your absolute value inequality is in the form, the absolute value of x minus c is greater than d, greater than or equal to d, where d is greater than 0, you can have it equivalent to x minus c is less than or equal to -d, or x minus c is greater than or equal to +d. You have that split. And if you end up solving for x, you get x is less than or equal to c minus d, or x is greater than or equal to c plus d. So again, you have this big idea that you started with greater than or equal to, and it ended up with an or compound inequality. So the value of absolute value of x minus c represents the distance a number x is from a fixed number c, so it's a center now, again, no longer just the origin, on the number line. The inequality, the absolute value of x minus c is greater than or equal to d, means the distance a number x is from the center c on the number line must be greater than or equal to a number d. Again, there's a trick you can think of, again, in the words. This is greater than. So it's, again, it's in the word, just like less than, you have greater than. So it's just a trick to kind of remember which compound inequality goes with which absolute value inequality. And again, we get this idea that we're splitting into 2 different signs. You have less than or equal to and greater than or equal to within the compound inequality, where you only started with greater than or equal to. So there's a little trick. You just have to remember which absolute value you're talking about, which absolute value inequality you start with, and then how do you split into these 2 different inequalities. So here's an example where a graph of the solution set of an absolute value inequality is shown, and we want to work backwards. We want to write the inequality. So knowing what we just talked about, this graph is an OR graph. This is an OR compound inequality, and it looks like we have a center of 2, and we have a distance of 1, 2, 3, 4, 5 in either direction. So if it's in the form, if this is C, and now we have D is 5, we know that it's the absolute value of x minus 2, and we're comparing to 5, and the fact that it's an OR inequality means we have to have greater than as our inequality. And it's circled, we're including the endpoints. It's a closed circle at our endpoints, so it's equal to. So we have our absolute value inequality of x minus 2 is greater than or equal to 5. Here's 2 more just for good measure, for good practice. So we have the graph of the solution set. Now this graph is an and compound inequality. The shading is in between 2 values. And it looks like we have a center C of negative 1.5. So that would be the absolute value of x minus negative 1.5. Then we have a distance of 1, 2, 3, 4.5 to each endpoint. Again here, a half and 1, 2, 3, 4. So our D is 4.5. Now, if it's an and inequality, you have less than as our sign, or less than. And these are open circles, so we're not including them. If we clean this up a little bit, minus a negative, we can write as the absolute value of x plus 1.5 is less than 4.5. Again, now exercise F. This graph is an OR compound inequality. You have your shadings opposite, away from each other. It looks like there's a center, C, here, equal to negative 4.5. And we have a distance from each point of 1, 2, 3.5. So we have a distance to either endpoint of a half, 1, 2, 3. So that means in my format, I'm going to have x minus c, or x minus negative 4.5. And my distance is 3.5. And if it's an OR, you have greater than, or greater than as your symbol, your sign. And it's an open circle, so it's not equal to. If we clean this up, our minus a negative is going to give us the absolute value of x plus 4.5 is greater than 3.5. Again, so you can work from graph to inequality, inequality to graph, but it's just the big idea that less than is going to give you an and compound inequality, and greater is going to give you an or inequality.